minutes left in class. We are going to try to cover as much as we can regarding directional fields. That's really the one part of the syllabus. This is pronounced two ways: Euler's method or Euler's method. Both pronunciations are accepted. Euler's is the more European pronunciation, but you also sound way cooler. If you know it's actually Euler's. Yes. All right. So the idea of a slope field or a directional field, slope field or direction field, is that you want to be able to understand the relationship between y and y prime. That was discussed briefly in the homework. What's the relationship between y and y prime?
Oh, you're asking why.
Y prime is the slope line.
That's the literal. Y prime is the derivative of y. Yeah, but what does that mean in terms of the graph?
Y prime shows the slope.
Y prime shows the slope of y, correct? Right. So if y is increasing,
Positive.
y prime is positive. If y prime is decreasing, y is negative. I'm sorry. If
Clutch.
y is decreasing, y prime is negative. Yes. Okay. Here we go. All right. So the idea here is, given this problem, graph the solution to y prime equals x plus y. You can only use slope fields or directional fields when you have a first order differential equation with x and y. And the idea here is there are lots of points on this graph, and we have an idea of what y prime is. Y prime is xy. So, for example, if the coordinate, and I'm just going to make up a little T-chart here. If it's a little different than a T-chart. So, you don't necessarily need to do this chart every time, but for the first time through, there's going to be a lot of points we can put here. Essentially, we can pick any coordinate we want here. And, for example, if I pick the coordinate 1, 1, right, that's located right there. If x is 1 and y is 1, well, what's the value of y prime? If x is 1 and y is 1, what's the value of y prime? 2. So what's the slope at, if the graph passes through, and it's not guaranteed, if the graph was to pass through 1, 1, what would be the slope of the graph? 2. So what we try to do is we try to estimate and draw a line with an approximate slope of 2 at point 1, 1. Now, you're going to do this many, many times. Fortunately, the calculation is not super challenging. For example, 0, 0, I'm just picking coordinates kind of randomly. If x is 0 and y is 0, then y prime is 0, correct? And a line with a slope of 0 looks like what? Straight. All lines are straight. That's going on the internet.
We got a 214 shots fired.
All right, so what else? Well, we can do other coordinates. For example, negative 1, 0. Now again, negative 1, 0 is right here. The slope is negative 1. So at this point, right here, we're going to draw a little line that has a slope of approximately negative 1. Now, I'd like to do this for as many points as possible. Do you need to do a big chart for it? You can probably do them in your head. Like, for example, if this is 1, 0, right? So this would have a slope of 1, right? Does that make sense? All right. Over here, if I just went along the x-axis for several points, as I go to the right, what's happening to the slope of these lines, right? They're increasing. They're getting more and more vertical. And a slope of 5 is going to be almost like a vertical line. So, like right here, for example, this is going to be what? 2, 1, so that's a slope of 3. Over here, 0, 1, slope of 1. Now, when you get over here, negative 1, 0, negative 1, 1, this is going to be a slope, a horizontal slope. Right? So you want to fill in as many of these as possible. Now, it's a little bit of a tedious process to create one. What do you mean the numbers? Pick any coordinate on here. There's no wrong coordinate. If I pick this coordinate, that's negative 1, 2, right? If x is equal to negative 1 and y is equal to 2, then y prime is equal to positive 1, right? And what does the slope of positive 1 look like? So what we're saying is, hypothetically, if the graph was to pass through negative 1, 2, it would have a slope of 1. We don't know that it necessarily did pass through negative 1, 2, but if it did, it would have a slope of 1. Does that make sense? So this is essentially like throwing a big net over the entire x and y axis. Now, I would say, honestly, going 5 in each direction is still a ton of points. You don't take a ton of, this would be what, 0, 2, so it has a slope of 2. This would be a slope of 3, a little tougher to draw. Here, this would have a slope of 4, it's getting even more vertical. Negative 2, 2, this is a horizontal line, right? And in fact, there's a little bit of a pattern here. All of these lines here would be horizontal, correct? Right? Negative 3, 3, negative 4, 4, negative 5, 5. Agreed? What we don't have is, we only have one negative slope. That's because, what would the slope be at this coordinate? So let's draw a slope that's negative 1. And in fact, what about all these lines right here? Aren't they all negative ones?
To the right of that is positive 1.
To the right of that is all positive ones. So there are some little patterns. Now, I'm not going to say you're going to be able to figure that out every single time. If you were to go, let's see, so here, 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 there's a bunch. You don't, I mean, obviously, as you look at this point, that's going to be another horizontal slope, right? You with me so far? What we need is a few more ideas, a few more in here. Like, for example, at this point, negative 3, 1, the slope is negative 2. So the calculations are a little tedious. Right? So the question is, do you guys agree all these are negative 2? Stop me if you think I'm making any errors, okay? Looks pretty good. All those places, at every one of those points, if you substitute it in for x and y, you get a y prime value equal to the slope of what I've graphed. Okay? All right, so now, so the idea here is, and the picture in your book is best if you look on page 573. That's probably going to be the best slope field you're going to get. The one that I have is not nearly, actually it's on page 572. That's my fault. But page 572 in your book has a good picture of this slope field. And the idea is, if we know that 0, 1 is on the graph, because it says that the initial value is 0, 1. If we know that this is on the graph, then right here, where I'll draw this red dot, right there at that dot is on the line. Do we know the direction the graph is moving at that red dot? Yeah. For the most part, this graph has a slope of 1. And as it goes to the right, what's going to happen when it gets to this dot? The graph should be increasing faster or increasing slower? Faster. So now the slope field is telling you, all right, this graph's going to keep increasing faster. And it's going to increase. Now, we didn't put any dots out here, but we know most of the slope field is rising extremely fast out here. This graph, as it goes out to the right, is going to keep hitting a slope field that's going to rise faster and faster. As we go to the left, well, we know we had a slope of 1, right? But now it's going to get to something that has a slope of negative 1. If I follow this slope of negative 1, well, now it's looking like if I keep following that slope of negative 1, it should go something in that direction. A directional field is going to do nothing more than give you an estimate of what you think is a solution to the graph. Do we have any questions for today? Because this, remember, it pointed me, this one is really the one that we had to look at. And it points you a little bit more left. That's a good question. But if you notice, if you tried to go right.
Bye, Brandon.
If you try to go right, it's against all the other slopes. So there's a better picture in the book that shows a slightly better curve.
Rest of the
Take a look
pancakes
at
are
that.
gonna cry.
YouTube